All right, today we're going to talk about Git. And Jasper's presentation a couple of weeks ago was really good. I liked his style and his approach to the topic, and so I'm going to apply some things that I learned from him to this presentation. So let's get started with, well, what is code? Okay, not really. Let's not start there. What is version control? Okay, we will start there. It's a system that records changes to a file or set of files over time, so you can recall specific versions later. So helps you with collaboration, helps you to understand what happened and why, gives you a place to experiment safely, and it gives you a backup. So what's Git? It's a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. So all the cool kids use Git. It's relatively easy to learn. It has a tiny footprint and it's super fast. Those are some of the reasons why people like Git. It was originally developed by Linus Torvalds, and the same dude that did the Linux kernel. So pretty smart guy. Did he do it in a weekend? Okay. Awesome. Yeah. All right, so here's a few Git commands, and I'm not gonna like spend time reviewing the API of each command. This is pretty much all you're gonna get, pun intended, right now. But you'll see them as I demo. We'll do a couple of demos in this Donuts. There are a lot more, so you either need to memorize them or keep an internet connection open so that you can go look at the docs on gitscm.com. All right, so we'll use workflow to introduce both Git itself and workflow at the same time. Hopefully that works. I haven't done that before. So here's a solo workflow. You start off by, well, one way to start off is by cloning a repository down to your local box. Obviously, another way is to just start one, initialize one on your local box. You make some changes to that code. You stage those changes. Git has the concept of a staging area. Once you're ready to move those changes from the staging area into the repository, you commit them. And then you repeat that cycle until you're done with your changes. And when you're done, you can push those changes and celebrate. This is a really good workflow if you're solo and you're working on one thing at a time. If you're going to collaborate or work on multiple features or bugs at the same time, you're gonna want to use branching, and so we'll get into that in a few minutes. So let's just demo that basic workflow. All right. Is that big enough for the back? Yeah? Okay. So I'm going to create an empty directory called things. This is Dr. Seuss themed, so thing 1 and thing 2. And then I'm going to initialize a repository. So that's our git init command. And then you can see success because that .git folder is there. So that's a do not touch folder. I think years ago there might have been a few things you needed to go do inside that folder, but I don't think so anymore. So if you find yourself in the .git folder, you're probably following a really old how-to article or something. So don't touch. And that folder not only contains your metadata, but also your data. So if you lost everything but that folder, you still have everything. So you just lost your working copy is all. So git status is your best friend, your best Git friend. You're going to use it a lot. So the output here is telling us that we're on branch master, and master is a branch created by default, and most people don't change the name of it. They just leave it. And typically in the Git output, unlike say NPM and other tools who give us really crappy messages and output, Git actually gives you some halfway decent output and even suggests what your next step is to do. So we're on branch master, we're at the initial commit, and it gives us this hint that we should create or copy some files in and then use the git add command to track them or add them to the staging area. So let's do that. All right, that probably needs to be bigger. Does that work in the back? Okay, thanks. I love it when people in the front answer, yeah, that's big enough. All right, so I'm modeling thing1 in JSON. And this is an arbitrary an example, but the git commands are 100% valid for what we're doing. So now, per the suggestion in the git status command, let's let's do a status again. So it's showing us that we have an untracked file, so that means a new file. So thing1.json isn't in the repository yet, and he's suggesting that we use git add. That's right. And this command's no news is good news, so that was successful. We run git status again. Now it tells us that there are changes to be committed, so they're staged, and those changes are a new file, thing1.json.
So that workflow diagram shows where we're at.
Ah, good point. Okay, so instead of cloning, we did a git init. We made some changes by adding a file, and now we're about to stage. Actually, did we stage those changes? Yep, we staged them. So with the git add, we staged them. So now it's time to commit them. Commit requires a message. Okay, a little bit of statistics in the output. And then if you want to see a history of your commits, use git log command. We have only one commit. So this ID is a hash of everything in the commit. Yeah, that's it. Okay, so then where are we at in the model? So we committed our changes, and in our case we're complete. If we weren't, we just keep going through that loop over and over again. We're complete, so we're going to push those changes. Before we can push them, we need to tell our local repository that there is a remote repository, except there isn't a remote repository. So let's go create one. So the command I need is suggested by Stash or Bitbucket. It's right here, right here. Cross your fingers. Okay, so this command is basically we're saying we want to add, we want to tell you about a remote. We want you to call it origin. That's a default name for a remote. It's very common, and some of the defaults in Git will use it. So we'll use it to get those conveniences, and then we give it the URL to that repository. Hopefully that worked. That kind of hung there for a second, or didn't scroll one or the other. So I'm gonna. Yeah, it's there. All right, so now we want to push our changes up, and that's the git push command. So let's see, where are we on the workflow? So right here, push changes, and we're about to celebrate. Grab a donut, everybody. The first time that we push, we need to tell Git about that relationship. So we're going to use -u origin master. So we're telling, I think it's called a, I can't remember, but there's some name for that relationship. And now, so from now on, we want to get push on that branch. We can just do it without those extra parameters, and since we told Git about that relationship. Okay, so celebrate time. Okay. Let's take a look at it in Stash. There we go. So there it is. There's our repository and our code. All right. So solo workflow. Let's talk about visualizing a little bit. So with the previous diagram, we visualized the workflow or your developer steps. Now let's talk about visualizing the repository itself. So we're gonna do a timeline, and the dot is the beginning of that timeline, and the arrow points to the future. The solid line is historical or past. Dotted line means future, so that means the present's right at the transition of those two. So let's represent a snapshot or a commit with a dot, and then let's bring those two together. So we have a line with dots on it. It's so beautiful. So that line represents not only time, but a branch of code. So in our case, we were on branch master, and we did just one commit. So we would just have one dot. In fact, I think I have a never mind. I'll show you that diagram later. Okay, so branching. Branching allows you to make changes to the code without affecting the main line. In Git, that's very inexpensive, and it doesn't take much disk space. It's very fast. When should you branch? Pretty much all the time, or very often. So let's update our visualization to include a branch. When you branch, you have to start from somewhere. You have to start from a previous commit, and that previous commit is called the base. So this commit right here is the base of this branch right here. So this horizontal line is representing the master branch, and this horizontal line is representing our branch called feature/XYZ. And in branch names, the slash is allowed, and it's treated similar to the way directories are treated in a file system. So it helps organize things, and they show up grouped together in most of your Git tools. So you'll find that this pattern right here of feature/feature name or bug/bug number is common out in the Git wild. You might see some diagrams with the arrow going the other direction. I think the reason they do that is because of in the Git implementation, a commit is stored with a pointer back to the previous commit, and so maybe that's why they put the arrow in that direction. But I like to do it in the direction of time, so I think you'll see it both ways. So watch out for that. So let's talk about branching strategies, because workflow matters a lot. It can have a huge impact on your ability to ship and also the happiness of your developers. There's several models. The only two I'm going to talk about today are Git flow and continuous integration. At the end of the day, you're going to need to decide what workflow works for you. Is anybody using other models that are named? Anybody using just like a flow they came up with themselves that works for them and their project?
Yeah, we do. We basically got rid of master altogether because we maintain our broad hash on our commit page.
Okay.
So anytime we have to do like hotfix, we'll just pull it down from there. And then we have our release branches, which are basically our currently running masters.
Okay.
Work for us.
Cool. Yeah.
Like
So
traditionally you have a master, it makes sense to keep that around, but because we have access to that hash,
you don't need it.
we don't.
Yeah. So Git's flexible. It's going to let you do whatever you want. So you got to just decide what's going to work for you guys. Git flow is a really popular one, and For the sake of time, I'm going to brush over this one. I'll describe it in general. The general idea is there's a master branch, and this represents what's in production. And each of the commits in master are tagged because they are released out to production. When you want to work on features heading towards a release, you branch off of master and create a develop branch. And when you start a feature, you branch off of develop and you create a feature branch. When that feature is done, you merge that branch back into develop. If there's a bug in production, you branch off of what's currently in production. You create a hotfix branch that represents that bug. You fix it, and then you merge that change back into master and release it. And you also merge that change back down into develop. When your develop branch is, when you think it's ready for production, you branch it to a release branch. And any changes there are probably because you found problems in testing. And so when you find one, you need to merge that change back to the develop branch. When you're done with your testing and you think it's ready for production, you merge that branch, that release branch back into master, tag it, and you do a release. I think that's the general idea. Everybody got that memorized? Good. Glad. Yeah. Tags are simply a marker. So you can use them for whatever you want, but I think the most popular use is to say, to mark a version number that you are about to release or you did release. Are there any other?
It's naming.
Right.
And instead of referring to it with a hash, you're just giving it a nice, friendly name.
Yeah, that's absolutely right.
That's essentially it.
You're giving a commit a name.
I use tags every time I release. I tag the version.
Yep, that's super common. Any other questions or comments? Yeah.
Some of our technologies here in the church, like Anton and stuff, also have integration to use those tags when you go to build your code. I just thought I'd put that out there because I know that we use it on our team.
You use that?
When we build our stuff in Anthill, we actually will give it whatever tag we want it to.
For anthill building. Okay. I'm sorry.
Oh, right.
He said they use, you want me to repeat it or did you want to?
Go ahead.
Okay. He says they use tags with Anthill when they want to do a build or a deployment. They'll tell Anthill which tag to use to do that deployment. Okay. Jared?
Like tools like GitHub as well, you look at tags and specifically interpret them as releases.
Okay. Yeah. Thanks. Okay. Some strengths of this Git flow is that it's well known. It enables free experimentation. It's methodical and controlled. It has good code isolation. Some weaknesses are it's pretty complex, especially if you notice there's a lot of merging that needs to be done and remembered to be done. It encourages larger and less frequent releases. Some people claim the opposite of that. They say that it encourages more frequent releases, but I haven't seen that. But it could probably be argued either way. And it makes continuous integration a little bit more difficult. So some folks have come up with a model that fits with continuous integration a little better, and they call it the continuous integration model. Who'd have thunk? I don't know. So this is a hyper simplified version of the continuous integration model. Here are some main points of it. Everything branches off of master. You don't have the develop or the release branches. Those concepts are not there. You release often, maybe even continuously. You still tag your releases, and everything you merge into master is production ready and might actually get released. And so if you have a feature that you've merged into production, you might hide it behind a flag to keep it invisible to the user until you're ready for them to have it. So the process of this bug branch might be somebody discovers a bug in production, so you branch off what's currently in production, You make this bug/bad thing branch. You fix the problem, and then you merge it back into master, and then you release it to production. The feature process is exactly the same. You might still namespace them with bug/ or feature/, but the process is the same. So I mentioned that it was hyper simplified. Development life is definitely not that simple, and things like this happen where simultaneous development occurs. It doesn't mean necessarily that you're going to have a conflict, but certainly conflicts do happen. And when this does happen, we'll use rebase or merge commands in Git to put us back into this situation down here at the bottom. And I'll demo that in a minute. So the strengths are that it still enables free experimentation. It's a lot simpler. I think it truly encourages smaller and more frequent releases, maybe even to a hyper degree there. It accommodates continuous integration, and that's related to its weaknesses, and that is that you have to have a really good technical foundation to use this. You need to have automated testing for sure, and the infrastructure to support it.
And that's just because master should always be a releasable thing, right? Like, the model itself isn't the issue, it's the fact that you're trying to make master always be quality code.
Yeah, so it requires some discipline there as well, that everything that goes to master needs to be ready to go to production. Yeah.
So say you have different environment lanes. Are you like, for example, you have that test stage. Do you build off of your feature branch all the way through stage? Or at what point do you actually merge and then build from master?
Is anybody doing that now that wants to explain how they're doing it?
On the Java stack, we pretty much use the continuous integration model. And we don't have, we build on, we develop and test on local branches. And then we just merge into master and let that continuous integration. And let our regular build run. Of course, our stuff doesn't, our continuous integration doesn't actually deploy anything until we actually get a version number. So.
Is that true for production or other lanes as well? So what does stage, is stage automatically deployed for you, and where does it get deployed from?
So because we're just building libraries, we don't actually, nothing actually gets deployed until we
Say so.
we deploy to Nexus, we don't deploy to the server. So
You just do that
so in our
manually.
case, this works really well. If it was an app, I might choose a different model. But for the library, it works pretty well.
Okay. Jared, do you have some?
You could also do it based on tags too. And you can assign tags to limits.
Yep. Okay.
Yeah, and that's probably what I do. Is I wanted to, if there was a particular branch I wanted to do,
Yep. Okay. And I don't know that there's a lot of us doing continuous integration. I think it's a goal that we should have, and so you might need to develop a hybrid or choose, a model that works for you. Maybe it's still Git flow. Maybe it's a simplified version of Git flow. Maybe it's a cross between the two, and you change it as you work your way towards a continuous integration model. All right, so let's update our developer workflow with branching. So in this workflow, this branch step is new, and the bottom half is radically different from our previous workflow, our solo workflow. I left off the fact that you typically pull before you branch. That's just to make sure that you're going to branch off of a current spot in the code to help you avoid conflicts in your code when you try to merge back in. So the top row is otherwise the same. We're going to make changes, state changes, commit changes, and if we're not done, keep looping through that. And if we are, this has a couple of variants to it, but the one I diagrammed is you'll push your changes, and you'll go and check to see if you have conflicts. And if you do, you need to pull those changes down into your local repository because they likely occurred because of someone else, right? And you'll rebase. You could merge. We'd strongly lean towards rebasing over merging. And then you'll push your changes and you'll continue that loop, that cycle until you can answer no to the conflicts question. So you might end up going through that loop a few times. And then you'll submit a pull request and celebrate. I didn't diagram the pull request process because that's, I think it complicates the diagram and it could vary, but I just left it as that you've submitted it and now it can go off and run through its own process. Yeah, let's demo rebasing right now. Okay, so let me try something here. Let me see if we can keep this visible while we rebase. Is that still visible in the back? Okay. Okay, so this is where we're at. This is the diagram I promised to show you later. Now is later, or later is now. So that's, we added thing1.json to our repository and we committed it. And so our local repository looks like this. And then we pushed it, so our remote repository also looks like this. So let's follow the workflow and make sure we're up to date. Obviously we are because I'm the only one touching this. Then we're going to create a branch. And somebody asked us to add hair to thing1. So that's what I'm going to call the feature. Okay. So that puts us right here. So I put a dashed line around the feature hair commit because we haven't actually committed yet. So that branch is still in a, I don't know, a pseudo existent state. Or at least, I mean, it's there. There's a branch, but I don't have a commit to diagram yet. So I made it gray and dashed. So now, so commit number 1 here in blue, that's our base for the feature/hair branch. Let's go modify. Oh, yeah, thanks. So the other way to do that, and the way I usually do it, I don't know why I did it this way, but maybe for the sake of demo, yeah, checkout-b, which will create the branch and check it out in one command. Thanks. So let's add hair to thing1, and I think hair is blue. So now we need to stage that change, and dot just tells it to stage everything. What's that? Good question. Yes, we do need to stage it. Let's do a get status. So it says there are changes that aren't staged for commit. Specifically, thing1.json has been modified. The next step is to git add. And then there's a shortcut to git adding, is to commit with a -a. We're going to do it the long way, so we're going to git add. Now let's do status again. Now it says there are changes to be committed, so they're staged, and that's the file we've changed. So let's commit that. Add hair to thing1. So now we just got a message saying that there's a bug in production. So we're going to have to walk away from this for a moment and go fix our production bug. Apparently, the color of a thing is not orange. It's red. And I'm disappointed that none of you told me that when I was coding. So we're going to switch back to master. Oops. And we're going to pull to make sure we're current before we branch again. And then we're going to branch for our bug. We're going to use the shortcut method. And this is not a big, but a bug. Wrong color. So now this orange and green, I apologize for not mentioning this earlier, but this line right here is my terminal pimped out, so to speak. This isn't a part of Git, so my terminal is telling me, it is detecting that I'm in a Git repository and telling me what branch I'm on and what directory I'm in. So sorry that I forgot to mention that before. I hope that wasn't confusing. Yeah, thanks. So we added hair and we committed, so that makes our commit a real boy. And then we made a new branch called bug/run color, and we haven't committed there yet, so maybe that should be dashed in gray. But this represents approximately where we are now. Any questions about the diagram or where I'm at? Okay. So let's see, we got to fix the color, right? Notice that the hair is gone. Does anybody know why the hair is gone? Right, I checked out master and I branched from master. Master didn't have that change yet. The only place that has that change is the feature/hair branch. So exactly right, thank you. So we need to change orange to red. And I think, what's next? Yep, stage it, git add. Yeah, git status, thank you, Matthew. Status, okay. There's changes not staged for commit, please stage them. So git add dot, because I'm lazy. And then we're going to commit it. Thank you. Yeah, git commit -a if you want to skip the add step. Right, a new file won't pick that up, and that's the primary reason I don't use it out of habit, because it doesn't get new files, and I almost always have new files. So, okay, what did we do here? We fixed color of thing1. Okay, and then we want to push that up to our remote repository so the build process can pick it up, or actually we can do the pull request process. And I don't believe we've told it about this relationship yet. Oh, good point. I think I ran into this the other day. It says it pushed it. I don't think it did. Let's take a look. So we have just master, so that didn't work. It lied to us. So we need the -u origin bug wrong color. So the output here says there's a new branch, and we have there's bug/run color, and we pushed that up to bug/run color. And because we did the -u, they set it up to track it. So now if we did that again,
Could you talk a little bit about the remote branches versus local branches and tracking?
sure. What is there anything specifically, or you just want an overview? Or
You did the push -u and you had to name it the same thing in order, but do you have to name it the same thing?
you don't have to name it the same thing. So I could have a local branch called Bruce, and it could actually track a remote branch of, Jared. Yeah, don't do it. And yeah, and you can have multiple remotes. While we're kind of clarifying things, you could have an origin that points to one central repo, and you could have maybe I think it's often called an upstream, or if you have two repositories that you're, like if you forked a product into your own repository, you would have an upstream pointing to the original product, and you'd also have an origin pointed to your repository. So there's a lot of flexibility there. You probably won't use most of it, at least not at first, maybe as you get more advanced. Okay, so where did I leave off? I forgot. I pushed. Let's refresh this. So now we have our bug wrong color branch. And the process here, let's see, where are we in our diagram? We're still right here, actually. And in our process diagram, we've pushed, and now we're going to check for conflicts. Now in GitHub, it would tell me, by simply looking at this branch, it would tell me if there are conflicts. But in Bitbucket, it won't, so I have to create the pull request to see that. So I'm going to create that. So we're going to create a pull request that we're asking for changes from bug wrong color to go into master. So create that. We're going to add some reviewers. And we're going to pretend like those reviewers have reviewed it. And we're going to notice that there's not a conflict message here. So we're good. We're clean. In fact, I think it might tell us somewhere. I don't see it. Maybe GitHub's a little more verbose about that. So we can look at a diff of the changes. Oh, okay, there's the rest of my page. Let me get this a little smaller or a little bigger. We're going to pretend like all of our reviewers have approved it, and we're going to merge it in. And now if we take a look at the source in master, we can see that the color is now red. Now imagine in your mind that I came in here and I tagged it for release, and then we released it. Okay, now back to our demo. So we were in the middle of adding hair to thing one. So let's check that branch back out. And where we left it was, actually we're right here. That bug we merged into master through Bitbucket. And now we're back on the feature hair branch right here, looking at this change, which we've already committed, but we haven't pushed. Is that your recollection of where we're at?
Yeah. So but wouldn't the 2A that's merged on master, wouldn't that really be 3? Because that's its own commit, right?
Because that's a what?
Its own commit.
Yeah, it's, you're correct. That's labeled incorrectly. This commit on the bug wrong color branch is not the exact same commit. This is its own commit. It has its own hash. And it has to have its own hash because part of the hash is its pointer back to its previous guy. Actually, maybe in this case that's not true. But so I should have labeled this 3. But you are correct. This should be labeled 3. And I will bump those numbers up in future slides. And in fact, 2B should have been 2A, and that should have been 2B, and this should be 3. So we'll fix that in a minute. Okay, so I have the branch here. Let's figure out where the heck I was. I'm on feature hair. There's nothing to commit. And so I'm ready to push that branch. So we need to define that relationship again.
Type head all uppercase.
What's that?
Type head all origin.
Origin.
Head all uppercase. You know, type out that whole thing.
Really? I didn't know that. That's cool. Okay, so similar message to last time. It set up a new branch up on a remote repository. Called it feature hair. Let's take a look. So there it is, feature hair and master. We can delete this branch because we're all done with it. I'll leave it there for now. What else? I think we're just ready to merge that, or to attempt to merge it. So Yep. Let's try that. Feature hair. I'm going to create a pull request to go from feature hair to master. We're going to add some reviewers, pretend. And there's our message. Can't be merged. There's conflicts that need to be resolved first. So let's look right here. So we're at this green conflicts box, decision point, and there are conflicts. So next steps are to pull, rebase, and push. And this is a little bit simplified right here, so let's look at what it really means. So we need to get those changes down into master. And this gets telling us that we're behind origin master by 2 commits. And fortunately, we can fast forward because we don't have any changes on master. So we're going to suggest that we use get pull to get up to date. So we're going to do that, and that pulled in those changes. Now to rebase, let me show you what we're going to try to do here. So the problem is that there are changes in this 2A commit that we don't have in the 2B commit, and there's a collision there. So we can't just merge this into master. So what we're going to try to do is change our base or rebase.
Explain that a little bit, like what the original base came from.
Right. So when we branched commit number 1 was our base to our feature hair branch. We want to change our base to be commit number 2 here, or yeah, I'm going to change our base to be commit number 2 so that we are free to merge back into master without any conflicts. Was there more you wanted to say about that, Jared?
No.
Okay. All right. So this diagram is supposed to illustrate that this little piece of diagram sliding forward or rebasing. So we're going to check out our branch.
Do you always rebase like that, or are there cases where depending on the change that's got to do it? Does it always work?
I think it always works. It's just a question of how many conflicts you're going to have. Sorry about that. Yeah, and that.
Wrong answer.
Hey. Okay. All right, so we're going to check out the hair branch, and we are going to rebase. Let me make sure I do this right. Okay, we're gonna rebase this branch from master, and it tells us that. Oh, sorry, let me finish scrolling here. It's trying to replay our work on top of a new commit. Yada yada. I don't understand all of what it's saying, but I do understand this. It's trying to merge it, and it ran into a conflict. Sorry, you can't see my highlighting. Failed to merge the changes. And you don't really need to look at the patch. I haven't anyway. I don't know what that would be useful for. If anybody else knows, pipe up. So we need to resolve this problem, and when we have, we need to get rebase -- continue. So what they mean by resolve this problem is fix it, fix the conflict. So we'll come into code, and Git has helpfully put some information in our file where the conflict is. This is the commit that added or changed this code, and this is the conflicting code in that same file. So we know we want red hair, so this does, Git has a whole bunch of magic, shall we say, because it's amazing, but you're going to have to do the merging. It can't guess at which is the proper thing here. So we do that manually. We need a comma here. So just like that, get rid of this stuff. Just get rid of the stuff that's in conflict, keep the stuff that's not, fix the things that fix it the way it's supposed to look. Okay, so we need to It's said to get rebase dash dash continue. So how about I try that? And that was the wrong thing to do. It says you need to edit all the merge conflicts and then mark them as resolved using git add. So that's what we actually needed to do next. So let's do a git status. Maybe I should have done that first. It's saying we're currently rebasing the branch, and there are some unmerged paths. Both of them were modified in this file. So git add them once you've fixed them. So next thing is to commit it. Oh, that's right, thank you. Okay. So let's do git status again. It says
You want to override origin.
say that again?
You want to override origin.
So I think I don't understand what that means, but I think
You pushed up a different, so right now origin is your last
oh, that's
state.
right. Yeah. So correct me if I'm wrong here, but basically we have just rewritten our branch history here. We've changed our base, and that differs from what's on origin. And so this message here is telling me they've diverged, and so you're going to need to fix that. And the way to fix that is to push it, push your changes, and force them. This is kind of a scary thing, except I'm not on master. You should never do that to master. But since I'm on a branch, I'm safe to do it even if it's wrong. Okay, so that pushed it up. We are now, let me see if I diagrammed that. Nope. So we're now in this state we are now rebased with this gone. Let's see what that looks like up here. And that fixed it. So here's our pull request, and that conflict message is gone. And if we look at commits, can you see that? Nope, never mind. Let's see. Oops, pull requests. Oh, yeah, there we go. Thank you. So there's our diff. Now it looks like we just added a comma and the hair to it instead of having the orange and the red, or the red and the orange, and then the hair. Okay, so I think we are ready to, well, I think we're just ready to have that pull request reviewed and merged. Now we can see the commit history where that was the first commit where I added the model. That's where I did the bug fix and fixed the color. This is the commit where I merged the bug fix in. Here's the commit where I changed the hair to red, and then here's the commit that merged the hair feature back into master. So that puts us right here. So we've merged the feature hair commit into master, and now those two branches are not necessary, so we could delete them, and our master branch would look like this. It does not. Yeah, they're still there.
As long as those commits have been pushed, they're always there. Well, that diagram indicates commits.
You're right. Thanks for the clarification. They don't disappear. And in fact, if you tagged this commit right here, the tag would stay after you delete the branch. It's still there.
So,
But we do recommend you delete your branches when you're done with them. You'll get cluttered and hard to manage and reason about and maintain. So at this point, I can delete that branch, and that branch.
So what's the difference between rebasing and just merging master into your branch? Yeah, why is that?
Jared, do you mind taking that one?
Cleaner commit messages. You can don't have all the merging messages. Cleaner committing message. If you look at your git log, you'll have less things in there, less noise. Sometimes you end up with duplicate looking commits when you do a merge that way too.
All right, where are we at? Yeah.
So in source tree, if you try to rebase, it gives you a confirmation message. And it says, make sure your changes have not been pushed to anyone else. What does that mean?
So because we're changing history, basically, that's going to mess up their repository. They're going to have to do a similar kind of a force thing to get their repository back in line, or to look like the central repository. Is there any more to it than that anybody knows about?
It's just that if you're like a rebase is you're essentially rewriting history, and if people have already inherited that history, it becomes harder to rewrite that. You have to go around. So you don't want to always just rebase on your local stuff, right? Not things that have already been kind of like spread apart to other people's stuff.
Right.
So if you ever pushed your feature branch to a node, it's not right.
Well, someone else is working off that feature branch.
So it's branch from that branch.
Yeah. Typically, you wouldn't do it.
So in my example, I did push. So I pushed my branch to the central, and I rebased it, and I pushed force.
Well, that would be another argument for using merge instead of rebase, because then you don't run into that possibility.
That's true. Typically, a branch is yours. Not always, but if there's a case where the branch isn't just yours and you're going to rebase it, you might merge, or you might just communicate to everybody if that's possible. Like maybe it's not.
So if you've never pushed, a rebase is fine. If you have pushed, a rebase is fine. No one else has touched your branch.
Yeah. So, like those type of branches are called like personal branches. Typically, in a personal branch, it's very common to rewrite history as you go. Like instead of maybe pushing a bunch of like WIP, it's very common to go and actually squash those to rewrite history, and your long-term record would be just basically like clean chops of deployable code.
So a lot of teams use a develop branch, which is a shared branch. Probably wouldn't want to use rebase. This doesn't work so well for the Git flow model.
Except for on your feature branches, there too it's fine as well.
So this workflow, certainly you can have any workflow you want. And there are actually variations of this workflow that work great with continuous integration, particularly based on our discussion just now. In this workflow, we've pushed changes to our remote or central repository, but you could instead pull first and look for conflicts and rebase them before you ever pushed. So you could rework this flow if you wanted to avoid that more so. Right. Yeah.
So, as you're checking in, you're having to put in a reason why or whatever the change was made, like a scripted tag that goes with that checking. Rebase, do you use all those descriptions?
When you rebase, you're actually keeping your commits,
Right.
and what's that?
You keep the commit, you keep the code that you committed, all the changes. If you lose all those tags that say why you committed.
No, you'll see the commits. So in this diagram here, this commit down here on the bottom that's labeled 3, it has a message on it, a commit message. That commit message is still visible in this line.
You can show them.
Yeah, good point. So commits. So here's the message for add hair to thing 1. That was my commit message when I actually fixed the problem. And then here's the commit when I merged them together. So I didn't lose any of my commit messages.
If you're using Jira to create your branches, you'll often use the Jira name as the branch name. But I also put the Jira number in the message, the commit message as well, so that when I delete the branch, I can still see which Jira that branch is tracking.
That's a good point. If you've got a branch that gives you some information, you might want to, like a bug number, you might want to put that in your commit message too.
Because in Jira, you can use Jira to actually create the branch and create the pull request right there in Jira, and it does it very handily. But if you are relying on that, because it'll use the bug number or the issue number, story number in the branch name. If you delete that branch later, then if you want to go back and try to figure out what branch was tied to what feature that you're working on, then having that in the commit message means that you can find it.
That's a good point. And so let's talk about commit messages. But first, you had a comment or question.
Going along with what Reese was saying, just having the Jira ID in the comments automatically attaches it to the Jira table. So even regardless if you create your branch on command line or in source tree, just having that git commit message, you're just going to attach things in.
Yeah, we have.
Especially when you're tracking things.
Yeah, we definitely have, the ALM team has integration between Bitbucket and Jira, thank you, and that's pretty cool. All right, so in the 30 seconds that I have left, let's talk about some best practices. Should I commit? Yes. Should I push? Yes. Should I branch? Yes. If you're asking those questions, the answer is yes. Except for this one. Should I push to master? No. You should always be working in a branch. So anatomy of a good commit message, and some reasons why you want to do this. 0 effort release notes, kind of cool. I've done that. Faster code research, and maybe bragging rights isn't a thing, but maybe it should be. Maybe it should be on a resume. So here's the rules we use on the Stack team. The subject should be 50 characters or less, but for sure don't go past 72. That's the first line of your commit message. You use sentence case, and you use imperative verbs like fix, add, remove, refine, improve. And the subject should complete the sentence, if applied, this commit will. And then here's some examples like those. Add, editor, config, update, yes, length settings, still Facebook's recommended. That one's 48 characters, any of you counting. For the body, it's optional but recommended. You separate the subject from the body by a blank line, and the tools key on that, so you want to do it. 72 characters in this case. You elaborate on the what, which is the what was in the subject, but you can elaborate if you need to. You explain why, so business reasons, logic, etc. And you don't explain how, you let the code diff explain how. So we put a template into our git config that whenever we go to do a commit, it just pre-populates our commit message with this template, which is horribly ugly, but it reminds us of the rules, and then there's 1 or 2 that don't, so watch out for that, but most Git tools will strip all the comment lines out, and so that ugly template's gone, and just our wonderful and amazing commit message remains. So parting words, we like Git. The GUI tools are good, but the command line's awesome. Branch, commit, and push often. Become a commit message artisan. We like the continuous integration model, and try to keep it simple and pick a flow that works for your project. And that's it. Any last questions?
How did you get that template to show up?
Which template?
The template for body.
Oh,
And you might make
if you look at the bottom there, the command's right.
because usually you just have like the bottom there, but how do you get it so that's what the commit? Oh, that's it. I have to read. Sorry.
No worries. And I'll publish this. So. Any other questions? Okay, thanks. Sorry for a few minutes over.